The Bike Club podcast is a collaboration between Beth Curran and Akshaya Parthasarathi.
The Bike Club podcast acknowledges the traditional custodians of the land we record on. We pay our respects to elders past, present, and emerging.
Welcome to Bike Club, a tech podcast crafted by the girls for the girls. Our mission to elevate, educate, and explore the exciting world of technology.
So tune in and remember, the first rule of Bike Club is to talk about Bike Club.
Hi, everyone, and welcome back to a brand new episode. And I think this is also just one more episode away from the finale for season 1. So all hands on deck today. The only difference from the previous episode is that Beth is now a year older. Yay!
Yes, I aged a year.
Yeah. And
in
any
about a
wiser?
month.
I'm sure you were wise enough.
I think I'm actually less wise. I think the older I get, the more I'm like, I don't know what's going on, man.
Maybe it's just, just parts of us just getting like, it's enough, like you're compartmentalizing your brain for like important things, which I believe for you, the last week could have been, I don't know, the Wicked soundtrack or something.
Yes, absolutely. And also, I feel like turning 26, so I just turned 26.
Yes.
2026 was way less scary than 2025 for some reason, because 25 feels like this big like milestone that you're like, oh my gosh, I'm mid-20s.
You have like so many expectations that you want to live up to and everything.
And then 26, I'm like, yeah, whatever. I'm 26 now. It's fine. So,
yeah, cool. Yeah.
Now I'm feeling chill about it.
Okay, that's good. Yeah, 26 is basically 8 years old since you've been a teenager. So this is like you're just
yeah, I'm an 8-year-old adult. Yeah.
You're an 8-year-old adult. Congratulations.
Thank you so much.
With that, do you want to take us into the rule for this episode before I get started on my report?
Yes, absolutely. So my rule for this week is a little bit more technical and code specific. But my rule for this week is always count your tables.
Oh,
this will save you so many headaches.
Okay.
When you're writing code and you're transforming tables and you're moving large amounts of data across, there's been so many times when I've like gone to push something or like tried to find something and the table's just way too short or way too long, and it's caused me heaps of headaches on the end when I could have just, when I was doing the transformations, checked it along the way. Just do some little checks. Just like once you do a count,
sanity checks.
check that do some sanity checks.
Yeah.
So yes, always count your tables because it will save you a lot of nasty surprises, like pushing something into a production environment that's missing 6 million rows, for example. Not that that's ever happened to me, but just a completely theoretical,
just a totally random number, nothing
that
personal.
could maybe happen if you didn't, count things. So that's my that's my rule. Totally not based on real life for legal reasons.
Counting your tables. Yeah, that's nice. I like
tables.
It's basic. It's necessary. Will it transpire to real life? We don't know. Only time will tell, but I like that.
That's true. I didn't really come up with like a real life connection.
It's fine. I'm sure we'll be counting tables metaphorically in life as well. There will be a situation.
Just sanity check. Just like keep your brain on.
Yes. Got it. Yeah, fun times. Good rule, Beth. Thanks for that.
Thank you so much. You're welcome.
So today's report was actually, I wanted to do this for a bit because this was a book that I read quite a while back. I don't usually pick up nonfiction until there's like something, I don't know, really, really, really juicy happening in there, right? That might not have been like the greatest way to describe this, but I think this book, which is called the Immortal Life of Henrietta Lacks, really signifies, basically the theme of our podcast, which is not giving women enough credit for what it is, for whatever that they've done and for whatever they've contributed to the field of science and just STEM in general. And it holds true for this woman in the book, the protagonist, Henrietta Lacks, because she did not, I don't think she's even fully, she's received credit and she's done such a huge, significant contribution to science, which unfortunately she wasn't even alive to witness. But it's opened up, like the story, like her story has opened up so many more discussions, specifically towards the ethical use, or the ethics, yeah, the ethics of basically not crediting someone
Mm.
when you're using their contributions towards your experiments and whatnot. Before I get into like all of that, let me give you a little bit of backstory about Henrietta Lacks. Born as Loretta Present in 1920 to a family of, well, a really poor family of tobacco farmers. She was one of 10 children, so they were pretty poverty stricken. And they were also growing up in Virginia, the United
Hmm.
States, and they were African American, so they were colored. So not only were they poverty stricken, but it was a time where a certain set of people just did not receive as many equal opportunities, and
Mm.
they were just, yeah, they were just not treated fairly. In 1941, around age 20, Henrietta Lacks married well, actually, Henrietta Pleasant married Day Lacks. And according to the book that I mentioned about, their cousins, Lax's cousins, encouraged her and her husband to move out into like a bigger town, into a bigger city, so that they could escape the poverty that came with being tobacco farmers. And after their marriage in 1941, the couple then moved to Maryland, and Lax's husband began to work for a steel company, and then the couple grew their family over there. So Henrietta Lacks had about 5 children. Before the birth of her fifth child, she mentioned to her cousins that she felt like a weird knot inside of her stomach. And she did not seek immediate medical attention at that time because, it wasn't anything pressing or whatever. She was pregnant at that time with her fifth child, and that's what she dismissed the knot to be. This
Mm.
was in 1950. But then a year later, this knot came back, but this time it was way more painful, combined with a weird type of bleeding. And then there was also a lump on her cervix as she inspected it. So
Mm.
at this time, she was like, okay, I need to seek medical attention. A little bit of like tidbit from the book was that prior to this, none of her family members were eager to go to a hospital. And their routine was literally to visit like this local Jesus statue, lay flowers at the statue's feet, and then say a prayer, and then rub the statue's big toe for like good luck. So that's how
Okay.
I mean, I think that brings into perspective about how much something had to be painful or serious for them to go
Mm.
inside of a hospital in order to actually seek help from a doctor. Henrietta decided to go to the Johns Hopkins Hospital, which at that time was the only hospital that actually treated people of color. They had a separate division or like a separate ward of the hospital where Lax would be treated. And at this time, the moment that they inspected her and did the yeah, they just performed a couple of exams, and then they were able to diagnose that Henrietta had cervical cancer. This
Mm.
obviously devastated Henrietta, but she decided to keep the diagnosis private while also seeking any kind of medicine or the continued treatment and chemotherapy without letting her family know because she didn't want them to worry. She received numerous tests during her time at the Hopkins Hospital in preparation for her first cancer treatment. The standard procedure was basically taking tubes of radium inside her cervix, and then basically you put those in as pouches. While radium is a radioactive metal that is like lethal to cells, it is also known to kill cancer cells. One of the times while she was receiving this treatment, she was on the operating table, and then the surgeon obtained two tissue samples from her. One was taken from the tumor, and one was just the normal tissue. The physician then placed the tissue samples in like a separate glass dish, and then this was sent to the Johns Hopkins hospital researcher and head of tissue culture research, Dr. George Otto Gay. According to the author, that wrote the book, Rebecca Skloot, she mentioned that this was apparently quite normal at the at the hospitals, and especially Johns Hopkins Hospital, to collect samples from patients without their knowledge. Sounds a bit like insane.
Yeah. Yeah.
Um,
Sounds
but
about right though for the time.
yeah,
Yeah,
for
I
the
didn't need
time.
consent.
They had like some kind of like an agreement, like an operational, just like an agreement, like a disclaimer that they would just sign at the beginning. And that kind of was considered as an all access
Mm,
pass, inc
mm,
including collecting samples from your body and then them doing whatever they wanted to do with it. At the same time, so uh, Dr. George Otto Gay was aiming to develop what was called an immortal human cell line, or basically cells that would continue to replenish themselves in the laboratory. Obviously, this was needed for a lot of very different purposes. At that time, probably just to study, I suppose, like the spread of cancer or to study,
mhm,
um, yeah, just diseases and how any kind of disease or any kind of cell culture cell culture related analysis. And I'll get a little bit into that in the later section. But basically, what he wanted was a never ending pot of water, I guess, put in like the simple way. And unfortunately, all his experiments were not successes because every time they would take a human cell tissue, do some work on it, it would immediately perish because they were not, it had to be a controlled environment, and clearly the cells were not capable of existing outside of a live human body. And you can't experiment on a live human body by injecting various different things. That would be illegal. So the cell culture analysis clearly required a cell that they have not yet come across. At this time, Dr. George passed it on to his research assistant, Mary Kubitschek, and he tasked Mary with the culturing of Henrietta Lacks's tumor cells and the healthy cervical cells as well. The research assistant, while skeptical at first, she then started to notice that these cells started to proliferate at a really large rate compared to the previous cell samples. The assistant named these samples, like she placed it in a culture medium and then named them HeLa, or HeLa cells. And that was also standard procedure, pretty common for physicians back in the day to use like the patient samples and then take like the first two letters of the first name and then the last two letters, or so the first two letters of your last name, and then come up with like that's the name of that. Again, you did not need any kind of consent or knowledge um, for the patient themselves, because they would literally just get you to sign an operation permit. And that
mm,
apparently stated that the patient was consenting to the hospital performing any operative procedures and anesthetic deemed necessary for proper surgical care.
right.
Really fishy. Obviously, that has changed. Thank God. But anyways, so the HeLa cell line continued to succeed the lab assistants' expectations because they just continued to grow continuously at a really unprecedented rate. Weeks after Henrietta Lacks has left the hospital following her initial radium treatment, her tumor cells continued to grow in culture at the lab, and it was proliferating 20 times faster than normal cells. And then by 1951, George Otto Gay informed his colleagues at the lab that he may have grown the first immortal human cell line. And then he offered them vials of Lax's cell, because by then he had duplicated
Mm,
this and performed whatever they wanted. And then they just distributed it to the rest of the researchers to do whatever that they wanted to do. Yet again, without Henrietta not knowing anything about this. Through
right.
radium treatments, there were side effects such as nausea and vomiting. There's currently no record of Henrietta Lacks experiencing any of this, but as her treatment progressed, they were able to notice that the tumor was beginning to shrink. But then by September of 1951, unfortunately, the cancer had spread all over her body, and like the entire internal organs were covered in like cancerous tumors. And then by October of 1951, Lax unfortunately passed away due to like absolute kidney failure. George Gay's lab came to know of her death and they requested an autopsy to validate the potential for further samples from various organs of Henrietta Lacks. But to comply with the law, which held that an autopsy could not be completed without permission, Dr. George Otto Gray actually needed permission from the members because, Henrietta had passed away. Physicians ended up convincing Lax's husband to authorize the autopsy, claiming that they would run medical tests on Henrietta Lacks, and that could produce beneficial health information for his children. It was pretty shady stuff that they just,
Mm.
clearly they wanted to use this for their own benefit. And then they claimed that this was something that they were doing in the name of science. As of 2020, the cells that George Otto Gay collected from Henrietta Lacks are some of the most commonly used cells in biomedical research, some applications which I will get into later. So, HeLa cells were not only the first successful immortal cell line, but it gave like this groundbreaking field to what cell culture is today.
Mm.
And what cell culture is also something that I will explain. But it all came from this woman who, as I mentioned, who was not even aware of this significant contribution that she was making to science. But not only was she not aware, but even the family members, like the continuing family members of today, were not aware until one of the researchers, not like the scientific researchers, but just somebody who was curious enough to look into it, Rebecca Skloot, as an investigative journalist. She went into all of this, understood where this was rising from, and then finally brought the much, much delayed credit to the Laxis family. And that happened only in 1975.
Mm.
So George Otto Gay claimed that his initial intent was to keep Henrietta Lacks's name private, maintaining the secrecy of the HeLa cell donor allowed for research institutions and companies to profit from Lacks's cell. Profit that none of the family members were ever able to see till this date. Apparently, there was this confidential agreement that was reached in 2023 between the family members that are alive today. But we still don't know, like, whether it was befitting enough to the significant contributions to science. So yeah, it was a story not only of delayed credit, but I think it opens up so much more discussion into ethical procedures that have come in. So she's
Mm.
not only just contributed to like the STEM environment in the most scientific sense, but also in conversations that involve ethics and in conversations that involve doctor-patient confidentiality, and various different things. So that's the story of Henrietta Lacks. And then in the next segment, I'm going to get a little bit into what exactly is cell culture and then look into the applications of it. All right. So cell culturing obviously is like the centric topic that we're going to be focusing on today. Up until now, cell culturing did date back, I think, all the way back to like the 1500s, where people were, looking through plants and understanding under a microscope what the cells look like and how everything works. But as time evolves and, as humans get exposed to so many different things, especially diseases, and as new drugs are developed in the market, cell culturing plays an even more important role because before you roll out something, I suppose, in the most computer science or, just like our data terms, before you roll out something into production, you want to have a good test case.
Yeah.
Unfortunately, with biomedical research, the test cases are not just, data sets. They're
Mm.
going to be like actual human beings. And
Heap of people, yeah.
yeah, and like, items from these humans that you want to research on. And this was, of course, George Ortogay's dilemma at that time, because even though they would collect these samples from their patients, these cells struggled to react properly in a way and would just will essentially die without the host, and the host here is
Mm.
the human body. It isn't natural for cells to exist outside of the human body to begin
No.
with. Exactly. So, cell culturing, which is basically just study and experimentation of cells outside of their natural environment, required a very controlled lab setting. And this includes not just the equipments that you would be using around it, but it also needed the ideal temperature, which is like the human
Mhm.
body temperature. So everything had to be 37 degrees Celsius, nothing more, nothing less. So, a step by step process would be like you collect the cells, and this could come from plants, humans, animals, and in this particular instance, it was from the human. You isolate the specific cells that you want to derive the culture from, or basically begin to culture. You prepare it with all kinds of mediums and you let it grow, or you feed it. And in this case, feeding it could be something like natural sugars like glucose, or you provide it the acids, vitamins, and minerals that it would need in order for it to grow. You first need it to proliferate before you can even start to do something on it. This would then require any kind of environment, as I mentioned. So you need all your chemical equipment, like you need your petri dishes, you need your
Yep.
flasks, you need your temperature control, the
Yeah, I'm
humidity
getting
control.
flashbacks to like year 10 science,
Yeah,
making little
exactly.
like cell culture
Yeah,
petri
but like,
dishes.
yeah, it's only, the fate of humanity in hand, as
Yeah.
opposed to, I don't know, like your like grade or whatever.
Yeah.
Um,
Yeah, they know what ours are gonna look like when we do it.
Exactly, yeah. And then basically the steps after that involves just monitoring and feeding these cells. You check constantly for any kind of growth or contamination or any kind of abnormality. And then you try to subculture it, which is like you try to prevent overcrowding once and if the cells begin to grow. So then you start splitting it up. And then finally you freeze it and you store it. And that is for when you wish to take it back out and then start doing other experiments on it. All of this, of course, you as an individual that is, just going about your day, having to do nothing with biomedical or biochemistry research, the basic example that, like, the basic question that you could be asking is, what does this have to do with me? Unfortunately,
Mm.
everything, because cell culturing plays such a huge role from the food that we consume to the injections that we would take in our body to the vaccines that we are taken to any kind of disease that could hit us in the future. A very good example to understand this would probably be with the COVID-19 virus. When we have something like an immortal cell line, and when we begin to culture it, like the first basis of culturing steps are done. That is, you've taken something, you've asked it to multiply, and you've got like, your batch that you want to perform your next set of experiments on. So, what you would do is, let's say the first thing that you want to understand is how does like the SARS CoV-2 strain, which was the COVID-19 strain, how does that infect cells to begin with? So, the replication that you would do in a lab environment is basically you take the virus that was grown in, let's say, the lungs from the human lungs, because that's we know that the COVID-19 virus hit a human's lungs first. So you would take those cells from the lungs, and then you would literally, I don't know, maybe I'm simplifying it too much, but you would quite literally drop the strain of virus besides that cell. And then microscopically, you would then understand how does this virus bind to the cell or the receptor
Mm,
on the human cells. And then you would understand how fast does it spread, or how does it exactly spread, and what is the activity of this virus that makes it so harmful to human beings. And in that in that line, another thing that you would understand is probably with an infected cell, like now you have a cell that has the virus. So then you introduce the potential drug that you might want to take as a vaccine towards that cell, and then you would see how does this drug prevent that particular virus from either entering it, or if the virus is already within the cell, then how does this drug help move it out. And
mm,
it's all just about understanding these kinds of activities. And this was the exact kind of what, well, one of the many application that was used with the HeLa cells. And that is how the antiviral drug remdesivir was identified as a potential vaccine element for the COVID-19 virus. That's all about cell culturing. And I think the easiest way to remember this was a very fun analogy that I came up online, which is like, let's say you're really interested in understanding your termite infection at home. So all you need is this never-ending supply of wood, and you
mm-hmm.
lay out these wooden planks, and then you introduce these termites onto these planks. So termites here essentially play the role of virus to a cell,
Yep.
and then you want to see how these termites, chew through different types of wood. And maybe you want to find like a
Mm,
termite resistant wood. So you
yep.
have different types of woods, you have different types of planks, and then you can start, applying repellents or poisons on these woods, and then you can see whether your termite still affects you or not. That's basically the essence of cell culturing. Though, it may sound really simple, I believe it's years in
Mm,
studying and understanding. And I think even today they are able to find advancements in cellular growth that is way beyond human comprehension. I found this really interesting article that quite literally lays it out as a timeline, and I'll link it in the description because
oh,
it goes all the way from 1951 to, as of now, 2014, where a couple of doctors won the Nobel Prize in chemistry for their work of using HeLa cells and the technique that allows for the live viewing of ongoing cellular process such as cellular growth. Yeah, it's still pretty much a very active phenomenon, the applications of which I'm going to discuss in the next section.
yeah, cool. Thanks, Akshaya. That's really interesting.
Have
I'm
you
always surprised by how like recent these things are.
I know, like just, I mean, 1950s feels like
Yeah.
now, but yeah, it was crazy because it makes me think like with what confidence did you administer drugs before
I
this?
know, it's wild.
It's
It's
very
really
wild. They're
wild.
just like, yeah, it worked for that person. So obviously,
Yeah, I'll just go
you
ahead.
can take it.
Yeah, she'll be right.
Specifically, the HeLa cells over the years have enabled scientists around the world to make massive leaps in like the field of science and medicine. Some of the highlights include polio eradication. So Jonas Salk developed the polio vaccine in early 50s, but was struggling for a way to basically test it and experiment it. And since HeLa cells were found the following year, by 1952, these cells were found to be both susceptible to but not killed by polio. And that made them like the ideal host. So then they could actually test out different kinds of vaccines, as I discussed in the previous section, how you would go about doing it. Apparently, there was a HeLa cell culture production laboratory at Tuskegee University, and the peak at its peak, it was shipping in the region 20,000 tubes of cultures per week. And
Mm.
polio, as we know, has obviously, decreased so much since the past few decades to a point where what I found was really funny was because in India it was mandatory for us to have a polio vaccine. So we all have that little mark on the left arm for the
Mm.
vaccine because it was so common for children to take that. But then I noticed that, it's not as common for people my age of in different countries, and kids today do not have to take it at all.
Yeah, interesting. I
um
don't think I had it.
yeah, I
I
know,
could be wrong,
exactly.
but I don't think I did.
Well, I mean, it was probably because it was not as rampant, given
Mm.
country by country basis. But it's almost like an identification mark to a lot of Indian kids my age.
Interesting.
And I think now we don't even need it. And well, I mean, that's because we've got that vaccine discovered
Yeah.
and we had a very successful host to test it on.
Yeah. Well, there's only a handful of polio cases left in the world, right? Like it's really
Yeah.
pretty much
Yeah, as of
eradicated.
2021, there was only six, so I can only imagine it go down since then. Another vaccine that we discovered was for HPV as well. So HPV vaccines were also a huge outcome from the HeLa cells. And the
Mm.
most recent studies on HPV have found that the virus can lead to a development of like a host of cancer types. So again, like the cell culture evolves from vaccine of that to even to cancer studies and just understanding the growth of these cells in that. COVID-19 vaccine, as I already mentioned, HeLa cells were playing a huge and vital role in not just about understanding the virus at play, but also about any kind of drugs and vaccines that would help to treat and prevent it. Another interesting application that I read was genome mapping. So
Mm.
there were like the first human animal hybrids that were created in 1965, which were by fusing HeLa cells with mouse cells.
Oh,
Um,
wow.
yeah, I know. And there was, this kind of exact reaction by the general public at that time. But apparently that accomplishment enabled great advances in mapping genes to like specific chromosomes, and then that
Mm.
finally led to the Human Genome Project. So,
Yeah.
completing human genome sequencing in 2022 was all possible because of HeLa cells. And genome mapping is being used in stem cell research, and it understands potentially the different trajectories with applications in regenerative medicine as well. So,
Yeah,
it's
interesting.
that would be like a very I don't know, out of a Marvel movie understanding. Like it took me I was immediately thinking Amazing Spider-Man, lizard human being, growing your
Yeah.
arm out of
Yeah.
nothing.
It
Um
like gets chopped off and you like, yeah, regrow
yeah,
like a lizard.
that's cool. Yeah,
Yeah.
I'll grow another one. Yeah, I know. Yeah, just really, really different applications. But I think the most vital of them all, I suppose, would be, or the most poignant one is probably the ethical concerns. Once again, how much ethics between doctor-patient confidentiality has evolved since
Mm.
then, how much ethics concerning human subjects and performing and testing on human organs or yeah anything that they would give out willingly has changed, and we all have one woman to thank for that.
Mm.
So yeah, even though she never lived to see the legacy, I'm glad that her family members were able to realize of the biggest contribution that they could have made to humankind. And it's a great reminder that, you know, we really do need to start giving credit for things like this. It's how important it is. Some of the parts of the book are actually quite heartbreaking. If anybody is ever interested
Mm.
in reading Rebecca Skloot's Immortal Life of Henrietta Lacks, it's quite sad because she does interview with the family members, and they're talking about how, they say we've made a really big, important achievement, but the lives that they lead do not reflect that. And it's quite heartbreaking, but hopefully whatever agreement that they've reached with this, there was this company that apparently profited the most out of HeLa cells. So hopefully whatever settlement they provided was justified. That's all.
You hope so.
Yeah, you would hope so. But yes, that brings us to the end of this episode.
Brilliant. Thank you so much, Akshaya.
Thank you. I hope you enjoyed that.
I did. Very different to what we usually do.
Yes, I know. In this, the woman was not directly involved in like creating something, but I mean, it is her if it weren't for
Yeah,
her
no, it's an
body.
amazing story.
Well, that pretty much brings us to our second last episode that we have for season one. Beth and I
Yes. Oh
have
my
some
goodness.
ideas for the last episode, and we're going to keep it really informal, just have a chat about a lot of different things. I think there's some couple of topics that we do need to cover.
I'm racking my brain, but I'm sure I can.
Advancements in our life, I guess. So yeah, just talking
Oh
about
yeah. We can talk about that.
yeah. So yeah, a couple of interesting stuff. Keep an eye out on Instagram because we have put out our next book club read. So let us know if you've already read it, if that's something that you like. Like, are you getting encouraged to read more? Do you have any other books that you might want to shout it out for the rest of the community to hear? Because that would be great. And also let us know how you liked this episode and Henrietta's story. Do you have anything to add, Beth?
No, I don't think so. Other than hope you enjoyed the season, and we'll see you in the wrap-up episode. And keep the suggestions coming for next season because got so many more people to cover.
Yeah. All right. See you, everyone. Bye.
Bye.